All right, we're going to consider some functions below. We have the graph that extends from an x value of -2 all the way over to an x value of +2. Now, because this x value of -2 doesn't technically count on your graph, our domain will run from -2 to +2 with parentheses on the -2 and a bracket on the +2. When you're trying to determine domain and range for a graph of a function, ultimately you're looking for the leftmost and the rightmost x values, and we've located those. If your graph doesn't count that value, use parentheses. If it does, use a bracket. When you switch over to looking at range, you're interested in all the y values swept out by your graph. Well, this graph has the lowest y value of -3, and because the graph actually hits at -3, we're going to count that value with a bracket. At the top of your graph, 6 is the maximum, and it counts, so we'll use a bracket at the 6. Below the domain and range, you will see notations like f of -1, f of +1. These are problems where you're given an x value of a point on the function, and you got to come up with the y value. For example, if you go to your graph where x is -1, what's the y value here? It's -3. Good. F of +1, find the point where x is +1 on your graph. The value of y is also -3. For f of 0, we go to this point, the x-coordinate's 0, the y value is -2, and so that's what we report as our function value. F of +2, that's up here where this closed dot is, and that has a y value of 6. Now, back to that open point, the x value there is -2. If you were asked to find f of -2 for this particular graph, it does not exist because that point is not filled in. Looking at the next graph, we're also asked to find domain and range and then some function values. The domain, if you go to this graph, the leftmost x value is -1, and that's where our graph starts. As we weave through, as this graph goes downward, it still gradually goes right. Since there's no end to how far right or how large the x-coordinates on it are, we use an infinity to just say, hey, this graph keeps going. On range, you change your train of thought to bottom and top y values. Because that graph goes down forever, it dives really deep into the negative y values. So deep, we call it negative infinity. And then as you work your way across, there is a peak. And notice over here, this is a y value of 7. The graph goes a little bit higher than 7, so you can just make up a number it doesn't go quite to 7.5. So I would say 7.2 or 7.3. That'll be close enough for WebAssign. Back to function values, where x is -1, our y value is 4. Where x is 2, we have a y value of 7. Where x is 0, we have a y value of 3. Where x is 3, we have a y value of 0. In our next graph, we have a piecewise defined function. This piece extends left forever, deep into the negative x's. This piece extends far right into the positive x's. Because all values of x are accounted for, even at this jump, we still account for the 1. All x values can be accounted for by this graph, so its domain is negative infinity to positive infinity. Switch your mind over to bottom and top y values. At the very bottom, the y value of -4 doesn't count, so we'll use parentheses. As we work our way upward, the graph goes up forever and y's get really large the farther up you go. Switching to function values, go to the graph where x is -1, and you'll find a y value of 5. That's your function value. F of +1, we have an open circle and a closed dot. The closed dot is the one you count. So where x is 1, our y value or function value is 3. Only count the closed-in dots. Where x is 3, on the graph we have a y value of 4, and where x is 2, on the function we have a y value of 0. For this parabola that opens downward, all values of x are accounted for. This side of the arch, the x's go really negative. They don't go left real fast, but they do continue to go left. That's where x is negative. And on this side of the arch, your x values get positive. Again, they don't go over fast, but they do continue to go over. All x's can be found on this graph. Switching over to range, we're looking at bottom and top. Y values. Domain is left and right x values. Going to the bottom, we have no lowest y value, so we use a negative infinity just to illustrate that the graph goes down forever. At the top of the parabola, we do have a highest y value, and that's 4. Since our graph exists when y is 4, we use a bracket. F of -3, find -3 on your graph, the y value is -5. F of +3, find +3 on your graph, the y value is -5. F of 0, that has a y value of 4, and f of 2, x is 2, that carries a y value of 0. Those are our function values. To finish off this video, we're going to look at what's called vertical line test. A vertical line test just makes sure that each unique x value only has one unique output. So one input, one output. Visually, the way to verify that is when you put a vertical line through your graph, you'll only be able to strike it one time. No matter where you are, a vertical line will only cross this graph once. One strike is a function, that's yes. 2 or more strikes means no. For example, if x is 6, on this particular graph, you have a y value of approximately 2, and also a y value of -2. Now, in order to be a function, a unique x can't produce 2 or more different y's. So that is a visual violation of what a function means. 2+ strikes is not a function. Only one strike, yes. So just that, remember that as complicated baseball. One strike's okay, 2 or more strikes is not. In these graphs in the bottom, the circle to your left, if you put a vertical line through, it's possible to strike more than once. That's not representing a function. A unique x can produce 2 different y's. On the graph to your right, this one does represent a function because no matter where you put a vertical line through, you're only going to strike that graph once. It's okay if you have a gap or any x values that aren't defined. What we're looking for is 2 or more strikes with one vertical line. One strike's okay, 2 or more is not.